Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. It's great to be with you back on the HFE Hub, and today I've been chatting with Catherine Burns, who is a professor in systems design engineering at the University of Waterloo in Canada. Professor Burns is one of our keynote speakers at the Human Factors and Ergonomics Society conference happening in November in Brisbane. So I'm very excited this morning to be chatting with Catherine Burns all the way from Canada. Catherine, thank you for joining us.
I'm delighted to be here, Sharon. Yeah, really looking forward to our conversation.
Yes, so am I. And I believe that you're responsible for systems design and advancing research in health technology. So maybe you could tell us a little bit about that.
Sure. Okay. Well, I'm a faculty member here at Waterloo. I'm in the Faculty of Engineering, actually, which is where our Human Factors program is located. I think that's a really great positioning for anybody in Human Factors, because you get really close to the people who are actually developing the technology, right? Which means you're kind of waving the flag a little bit too, right? Because you have to kind of let them know that, hey, you got to stop, hang on, wait a second, let's think about how that's going to interact with people, right? I have to say that is something I've been kind of waving that flag for a long time, because you're always if you're in that kind of a role where you're kind of surrounded by, the really brilliant technical people that we have, they actually need to understand that there's also that other part of that conversation, right? That if they want their technology to work for people, and they want it to be successful, they have to take that step back, right? Sometimes they're really gung-ho to move ahead and, make the very cool thing work, but they actually need to take that step back, think about who they're going to be designing this for, really, and how's it going to work for them? And also to understand that, that we are a field, right? We are a field of expertise and professional practice, and we've been doing this for a long time, and we've got methods. We know how to do this. It's not just, oh, do you think it's going to work? So that's kind of the other part of it, is I think, working with a lot of people to convince them that we actually have quite strong methods to anticipate and understand how technology is going to work for people. And that's really a strength of Human Factors, but it's something we have to keep communicating.
So before we talk about the projects themselves, tell me about the journey into Human Factors for you.
Yeah. I think I started engineering, as a student, just because it seemed like something that was practical and probably that it would pay well at the end of the day, honestly. But as I started in that journey, I think what I found most fascinating was the kinds of problems that I thought would make a difference in people's lives. And so that's really where I think it was around third or fourth year, we had a professor in my program who taught ergonomics, and that was really the start of it. And it really kind of, I think it blew me away in some ways that I could actually take, the more traditional engineering skills I was learning about, physics and statics and dynamics, and actually start applying that to human work and looking at, problems in lifting and injury and stuff like that. All of a sudden, for me, that made sense. I wasn't the kind of engineer who wanted to build bridges and stuff like that. Not that there's anything wrong with that, but I really liked the fact of actually understanding how people worked and making their work life better for them. So for me, that was really the start of my journey. That was a while ago, right? I mean, quite honestly, and from that, it kind of expanded. I think when I was applying to graduate school, I was still quite broad, and what I was looking at, I was, I'd started to transition to thinking about Human Factors, but I'd also applied to programs in healthcare, which has become quite a strong part of my research lately. So I just knew I wanted to have this impact on people, and that's when I think kind of got intrigued by Kim Vicente, who ended up being my supervisor through graduate school, was just his mission that you could really, through design, you could actually improve how people worked. You could actually make things better, and that we could be quite deliberate in how we did that, and that there were these big complex problems, this was coming off of, the early days of cognitive work analysis, which has been a method I've used throughout my entire career. But it's really just a way of saying when the problem is really big and complicated, how do we start breaking that down in a way that's going to allow us to design things better for people? How do we start to understand their work better? I think that's been one thing that I think has been a theme for me throughout my career, has just been that kind of respect for people who are so good at what they do. They're so good at what they do, and they're, we study human error, but, we also know as human factors, people know humans trying to make an error. They always think that's the worst ending to the story. Oh, you read this in the news, blah, 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 caused by human error. It's like, no, that's the start. That's the start of the story, right? Because why? Because nobody's trying to make a mistake. Everybody wants to be good at their work, right? So every time we see these, errors or these failures or, these things that happen, we know that there was something in that work environment and the complexity where that person did not have enough support to handle that situation, and that's a design problem, and I've always loved I think that perspective of opening that up, and that we can do things better, we have these methods and approaches, whether it's, cognitive work analysis, but, I use a whole bunch of other approaches these days too. Kind of learned that they're all kind of trying to solve the same problem, but they all open up the problem in different ways, and I think that's where some skill starts to come as a practitioner, is how do you, I think every human factors person should have this big suitcase, conceptual suitcase of things, right, that they can open up, right, because there are times where, cognitive work analysis is great, but there's times where really the hierarchical task analysis is what's going to be most convincing, or your context is the biggest problem, and you're seeing that the context is influencing the situation, and so there's an awful lot that we can bring to bear on it. And I feel like I'm drifting a bit, but
oh no, it's a great segue, to be honest, because health is very complex. There's so many occupations under one roof, and if you're in the engineering department, you could be going anywhere in the hospital, really, within at least a hospital environment. So let's just maybe talk about how or maybe the question is, what kind of projects have you been working on? What technologies have you been developing in health?
Yeah, so I'd say 90% of my work right now has been focused around AI. Okay, it does seem to be the problem of the moment. I'm going to be a little bit, adding a bit of perspective. I don't think it's a problem that we haven't faced in human factors at every new form of technology, whether it's, automation. I remember whether you're studying pilots using autopilots, or, we've always kind of studied these things. It's a technology that's been advancing quickly, and it's complicated, and it's, the technologies, the versions that are coming out right now are not doing a great job of syncing with human decision-making and providing that level of support. And so that's where I would say 90% of our research is right now, is try to make that case, I guess, that AI it's not magic. It's not really all that new. It can do some fascinating things, that's for sure. But at the end of the day, if we want people to work with it effectively, we have to go back to our very traditional things. We want to keep the human in the loop. And we want to respect the strength of the human decision maker. And there's a whole bunch of different ways we can design AI. But, to be part of that and to do it correctly, we need the human we need to be thinking about that, how it's designed in ways that it's going to support human decision making. So what does the AI tell the human about itself, about its limitations and its boundaries, and does it? And that's what you see right now with the technology, right? Is it's kind of unbounded. It's been moving really fast. Everybody, people are popping out AIs, and they're not telling you what data set it was trained on or where it should be used. And they're making the same mistakes that we were seeing with automation, 10, 15 years ago. And so all of these are really kind of interesting questions. So that's what we're looking at. We're looking at what are the design options with AI, which ones would be better for human decision-making, Should people, where in the human decision-making loop, should the AI come in to support people? What does it mean if the AI isn't completely reliable? How dangerous is that going to be for people? If the AI is going to make a mistake, or the person's going to apply it in a context it wasn't designed for, what is that going to mean? Are they going to be aware of those boundaries? I think almost everything, and then, for me, it's always been kind of human factors first, right? I mean, we focus on method in my lab. We focus on thinking about human decision making and the method, and then throughout the years we apply across different problems. And right now, healthcare is a big focus for us, but we really do, in many ways, the same work depending on the various technology. So I'd say my program is about 80% healthcare applications right now. But we're still also active in automated vehicles. We pick up finance projects from time to time. It's kind of, if the problem's interesting and complex, for me, it fits in my portfolio, because I'm kind of really focused back on those methods and that decision-making support. How do we keep kind of opening up that design problem further and further, so that people keep designing things well, that people can work well with, right?
Yeah, so maybe you could tell us about a project that you've been working on, or something recent that's been interesting.
So I've got a couple good examples, I think, of the kinds of issues that we're seeing right now. So one thing we're looking at a little bit is risk scores. Okay, so one thing we see in healthcare, and we see this in a couple of different contexts, because I've got two projects where these kind of come into play. Just to kind of give you an example, one is like in sepsis, right? So sepsis is a very fast moving infection, or body's reaction to an infection. It happens, the person's already sick, but it kind of flips over into sepsis within a matter of a few hours. They can have serious organ failure leading to death. And trying to predict the patients, for example, that will have that kind of an event is very important, right? And so right now, a lot of the technologies are they develop what we call a risk score. So depending on different components or something, these come out, and it's very kind of trendy right now. We kind of have a project right now where they're very interested in the AI generating this risk score, and immediately, from a decision-making standpoint, that opens up a lot of kind of questions, right? Because that human has to respond now to that risk score. And let's say they're scored out of 7 out of 10, right? First of all, we have to know if 10 is bad or good. But then we need to know what happens, right? Is it actionable for the person? If I tell them that this person's a 7 and that person's an 8, does that make a difference from a decision-making standpoint? And the other thing that becomes very important are kind of the components that go into that. So when we work with a clinician, we'll find out that it may make a big difference to them how that, let's say the person's scores a 5, how that 5 was created. A 5 might, if it's just adding up two different things, what those things are matter. So they actually need more than just that risk score. They'll tend to need insight into the components that were influential in that risk score. And they also, the other thing I think we see with some of the AIs coming out is that they're not, the components that the AI model can pull out are not necessarily actionable components from a clinical perspective. And I'll give you kind of an example we're seeing from another project. We're working with a group that has developed a really nice, successful system, but it pulls out, I think it's pulling out something like a pH level or something like that, a pH score, which to them makes a lot of sense. But when we talk to clinicians about that, they don't know how to modify the patient's pH. It's not a clinically relevant kind of factor for them. So that actionability connection is kind of lost. And so those are kind of examples of the kind of problems that we're looking at. But to give you an example of a kind of the way we take our solutions. I've got a PhD student right now he's pretty close to finishing up. He's writing. He's happy, but he spent a lot of time looking at how optometrists diagnose glaucoma. And the differences between the expert optometrists, defined by people who, a bit of a combination of years of practice, but how many glaucoma cases they would see regularly, versus maybe the less experienced optometrists, looking at their different strategies, looking at, they have a whole bunch of different factors that would go into that. They look at pressure measurements in the eye. They look at family history, so some things that are very contextual and narrative. They look at fundus imaging, so they do some imaging at the back of the eye. So they have a whole bunch of different information sources, and so based on these kinds of conversations, he's learned that the experts kind of pull the information together a bit differently than the novices, right? And they look more at how things have been changing. They look at these patterns maybe at a kind of a deeper level. And then he's been working towards how do you develop an AI that starts to show that. So he's not developing an AI that just takes a simple, what we call a classification approach. It's not going to tell you this patient has glaucoma or not. It's going to work with the clinician a bit more, and it's going to say, I see a pattern in this person's pressures that they're going up. I see in their imaging, I see, we're seeing this kind of a pattern. We see in their family history, we see this kind of a pattern. So it works more at providing information at that component level. So you could think of it as maybe 3 smaller component AIs, and then it sort of pulls it together and it just kind of gives the clinician some feedback. It says, given these patterns, about 70% of the patients with this pattern tend to go on to develop full-fledged glaucoma, but it never says this is that. It leaves that decision making with the clinician in that case. And so that's kind of an example, I think, of how we would take a more human-centered approach. If we had taken a totally technology-driven approach, we would just code it, right? We'd get the AI just to give an answer. But we want to keep the clinician in the loop. We also kind of want to prove that we can do that. So he's been kind of taking this model out for feedback, and he shows the more traditional AI approach where it would just give you this answer, and kind of this is the approach that we could take where we show you, and this is what we're kind of hearing from how you like to work, and getting feedback on that. And it's been, he's been getting some really, really positive feedback on that's actually designing the system more, following the model of the thinking that the clinician would do in that situation, right? Yeah.
That's really interesting work, because I have a health background myself, but I'm just thinking this technology is keeping people, we have a thing in Australia which is called between the flags. So it's, looking at people's symptoms and signs within certain parameters. And that's really interesting. I think the other thing that's popped into my head is that it's important to make sure that the clinician is not relying on the AI for the decision, because we don't want to de-skill, but at the same time, what it's doing is showing them these patterns, as you've said, and things that can lead to other outcomes that they may not have considered or may have got sidetracked on or something. That's really interesting. So any other programs or projects that you've been working on recently outside of optometry maybe?
I've got one student who's looking at automated vehicles. totally different kind of domain, right? But she's really looking at, and I find this project's kind of extra fun because it came from one of my colleagues who's an expert guy at developing these. He develops the automation. He runs our University of Waterloo automated car that runs around our campus and stuff like that. So he's technically brilliant. And he came forward to us with a project, and he said, "Well, I'm going to apply for this grant in cybersecurity of automated vehicles." He's like, we're going to do all this embedded system stuff, And he's like, but then I was thinking, could they actually just hack the human? And I was like, yes. Yes. And he was like, would that be a vulnerability? I was like, yes. And he's like, would it be hard to do? I was like, no. And so it was very easy, in a very short conversation. made kind of point to him that the human, we do want the human in the loop. The human actually, I don't want to say humans are a vulnerability from a security perspective, but we do know that. We know that, there's studies of phishing, and we know that the technologies are getting much more clever at convincing you to click on this, update my software. There's a whole bunch of different ways that no matter how well designed his car may be technically to battle off, the cyber hackers, if the human that owns the car, downloads the wrong thing, or gets in the wrong situation, that would be something that, you need to think about, right? So we've had a really fascinating project just, she's been doing a lot of really interesting, she's been combining cognitive work analysis models with ACT-R models to try to get kind of a running prediction model about, if we set things up in certain ways, how likely is human performance to change as the person starts to deal with that situation? And are we going to see, actual physically measurable changes in the person's reaction time, and their ability to lane keep and stuff like that? Because the ACT-R models are quite well developed for the driving situation. And it's kind of neat because we're able to, at this point, run a whole bunch of different scenarios, at least in software right now, so we can start to anticipate which ones might be the most dangerous scenarios that they should be looking at. And then on the technical side, our faculty member who loves to work on security from the technical side can start thinking about, how he actually provides that support for that driver, so that, one, they might be less vulnerable to some of these things. But if they did start to happen, how would the car actually realize that the driver could be in a difficult situation? What can they do from their side,
So they're developing the panic button?
Essentially, right. Yeah. Or, at least a car that's, I think it's making them think more about their algorithms, that it's not just about the cybersecurity of the car. It's really about the cybersecurity of the human car system, right? And as the car maybe starts to understand a little bit of the model of the human, they can actually kind of protect it at a different layer. So I'm quite proud of that project. So I think it's been a really fun collaboration. I think it's been really great to work on that one.
That sounds really fascinating. So let's just come back to health for a second. And I'm going to ask a question. Why do we need the AI technologies in health?
We need the AI technologies in health because there's an awful lot of health care where we just don't actually have analytical models. The human body is still very complex. It's still largely unmodeled. And you're not going to have you're not going to have that kind of algorithm where you can actually mathematically model everything. But what we do tend to have in healthcare is we have tons and tons of experiential data that has been collected. A lot of it is still not very accessible. So that's kind of a problem across the healthcare system, is the utilization of the data. But the reality is that it has, in many cases, been collected across large groups of people, which allow these AI models to start to be possible. So the AI will allow some of these patterns to be discovered that we can't discover in other ways.
Well, firstly, how do you access health to put some of these technologies into play? Health is a big machine. Yeah. So do they come to you, or are you going to them? How does that work?
Yeah, I build a lot of partnerships. I build partnerships with our local hospital. I build partnerships with our clinical programs at my own university. And I kind of let the problems come to me. And then I think we open them up. I found to me that works best. It's a very bad model for me if I kind of look for somebody to help me solve my problem. I find that particularly in healthcare, people are really busy. They're going to be a lot more motivated if the problem is something that interests them. So we kind of start that way. In some ways, kind of co-designing the research. They start kind of with the the problem, and then I start telling them about what I think the approach that we can take on it, and we kind of develop a project that way.
Do you want to share maybe one or two outcomes of the work that you've done that's been groundbreaking?
I think one project we're doing just now, is just wrapping up, that I think is going to be kind of important is, so we've got our local hospital they're trying very hard to bring in innovation, right? The problem they brought forward to us, maybe it's not an obvious human factors problem, I guess. It depends. I mean, to me, anything could be a human factors problem. But they said, they've been trying really, really hard to bring in, these new projects, with AI and these new technologies, and they're very dedicated to it, and they want these to succeed. And our area in Waterloo is kind of a techie area. It's a big engineering school. We got lots of startups and incubators, and so it's kind of a little bit in the culture here. And so our hospital is really innovative and wants to be supportive on that too. But they were saying, in the last year, they had tried these 5 kind of pilot projects, and getting them engaged. And they put a lot of effort into them. They have to extract data from their system and work with their teams. And they said of the 5 projects, like only one succeeded, and they were getting disappointed in that, like what was going on. So they came to us kind of with that problem and said, what do you think? And so I had a couple students work more deeply with them. And just start looking at like why in one hospital would one project succeed and 4 others not succeed. And we know the technologies are pretty good, and we know that they're smart, designed by smart people, and they're solving problems. So what's really kind of going on there? And so I think as we opened it up, we started to, I think, really learn about maybe how maybe about the overall technology design process, I'd say. I think what we found was interesting about the project that was successful was that it was maybe more co-designed with the hospital frontline staff from an early stage. It was responding very directly to a need in their environment. And so that's, I think, so important. The other ones were certainly useful things, but they weren't exactly, and they weren't things that, they would seem like they were a need in the hospital, but they didn't maybe have that same pull coming for them in some ways as a successful project. So that's kind of super critical, right? That we're not always, we're not designing things for people, that we're designing things with people, if that kind of makes sense, kind of especially in healthcare. Yeah, you're not. So yeah, sometimes in human factors, maybe we do a little bit of that. We design for people, and we're not always as open enough to designing with people, which means, opening ourselves to co-design approaches and participatory approaches. And that seemed to be kind of the one thing, and and then there were also issues with like change management and stuff like that as the technologies were brought in, but they all still came back to the idea of buy-in, technology acceptance, and I was thinking, it came back to the technology acceptance models that we all kind of know, right? Because technology acceptance is another dimension of human factors. We know if the product is usable, we know if it meets the right need in the environment, and the need, the value is better than the cost, that people will likely accept it. But I think in healthcare, that buy-in is super critical. That value has to come above so many other things, right? It has to not get in the way of the workflow of very, very busy people. It has to not get in the way of patient care. Yeah, like, I don't know what healthcare is like in Australia right now, but in Canada, ever since, the people point at the pandemic as, where it really started to happen, but there's been a huge human resource problem. People are massively overworked. To try out something new takes a lot of capacity that they don't necessarily have. And so that project, that thing they're going to try, has to be such a clear win for them, and they have to see it really, really immediately, or else maybe, or you're going to have to wrap a ton of support around the team so that they can have that extra capacity to learn about it if you really believe it's going to be worth it in the end. But for me, that's been a really important project because I think it's opened up my mind as a human factors person to maybe back to this idea of designing with people, not just for people. And thinking more about, are we actually bringing in co-design approaches and these participatory approaches enough in our human factors practice? And are we missing something? And so for me, I think it's probably pivoting maybe how I look at things in the next few years, just from kind of having that experience.
I think that's really important because I think there's a fear about AI because it's something they don't understand. And so if they're involved in the project, I think there is quite possibly a better understanding of the technology itself and what it can and can't do, rather than just having something given to them that they feel they have to learn.
Exactly. Yeah, exactly. Yeah. And when they see they're getting their own input and they know that you're kind of designing the tool really, really to help them, I think that's kind of so important, right? And you're not just bringing a tool forward from, I don't know, the hospital an hour away. There's somebody developed this and thought it would be good for them and wants them now to try it out and pilot it. Yeah, that just doesn't seem to exactly be the model that works that well anymore, right?
Yeah, we've all been given something in the past that wasn't a good idea.
Yeah.
Hey, look, I'm really excited because I know that you're coming to Australia soon, and end of November in Brisbane for the Human Factors and Ergonomics Conference, and very excited to have you. And I'm wondering what you're going to be talking about.
Yeah, well, some of the same stuff, really. I really want to talk to people. I think we'll be focusing on AI, but I want people to know that I'm interested in a lot of things broadly. AI is just kind of, a hot topic at the moment. But I think some of the same themes that we touched on today, that I think it is super, super important that as a field, we realize that I think we're very critical to designing AI in really effective ways. And I think there's an awful lot of points in the AI design process and design cycle and a lot of opportunities for human factors to be involved. And I think it's very critical because to me, when I hear a lot of the people talking about the risks of AI, a lot of times it goes back to the humans out of the loop. So AI is going to do this thing that we can't stop. Well, that's a human factors problem, right? You designed it to do this thing without having proper checks and balances on it. You designed it without putting the person in the loop and having that supervisory and maybe human collaborative approach, right? I think that's going to be vitally important as we move forward, that as human factors professionals, we own that role in this new technology, and we kind of stand up and start showing people that this technology can be designed in really, really effective ways if we're very careful about it. We've got the approaches to do that.
Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.